So this is the exciting second part of this, right? Is that it says what is the velocity and position of the ball 1.1 seconds from its release, right? So it took 2.07 seconds to hit the ground. So 1.1 seconds is going to be somewhere on the way down, right? It's going to be like.
So we're looking at a point in time, and remember, people sometimes kind of forget how this works. These equations work for you.
Yeah,
you don't work for the equations.
That's right.
So let's go with some of the things that we knew. We knew that the original velocity was 8.212.
8.212.
And that's
so
going to stay the
in.
same.
Yeah. Okay, because we know he's jumping off the cliff. So that guy's 8.212. These guys are always 0 and negative 9.8.
Never
right?
changes.
That we're accelerating with gravity up and down 9.8 meters per second squared, right? And we don't have any acceleration horizontally, right? And then the 1.1 second is the time for, well, both sides.
Put it on both sides.
1.1 seconds. Okay. And then what else do we know? Oh, we know that it's a purely horizontal velocity to begin with. So we know that initial velocity is 0 on that side.
Now, the reason why we're not filling in the x's right now is because we're talking about where is it after 1.1 seconds. So we're going to use our equations to do that. The very first one we can do real quick is we can figure out its horizontal position super easy because v equals x over t. So if I want to know the position,
right?
It's x equals average velocity times time. And so it's going to be 8.212 times 1.1. That's it. Simple as that.
Okay, so 8.212 times 1.1. That's 9.03.
Okay, now if you'll remember, last time we knew that it landed 17 meters from the base, but at this point it's only at about 9.
Yeah,
so
it's
the
a little,
full distance is 17.
Little more
so
than
it's a little
halfway.
bit more than halfway down. So that's good. So now you're looking at the other side. We have an A, a T, and a VI. What can we do with that, kids? We can go.
Let's find, let's use VF is VI plus AT, right? And remember we have to use only things on this side to find it. We can't be like using that, right? Okay, so let's find the final velocity. That's going to be 0 plus negative 9.8
times 1.1.
times 1.1. So basically that's just negative 9.8 times 1.1. That's negative 10.78.
Okay, so that's going to be its velocity. We'll be able to figure out the overall velocity at some point, but we still got to figure out the x.
Yeah, let's figure out x.
And we can do that with x equals VIT plus 1/2 AT squared.
That'd be the one to use because you know this, this, and this for sure, right? So x is VIT plus 1/2 AT squared.
VIT cancels out because VI is 0.
Yeah.
Makes it awesome. Now, I'm always kind of lazy. I always go shortcut. I just go negative 4.9 times 1.1 squared because that's half of negative 9.8.
I'm not smart enough to do that. Okay, so we get negative 5.929, is that right?
That's correct. So it's down. Now, the whole cliff, remember, was 21 meters tall. So it's you know, where Mr. Moran kind of drew it here is about right. If this whole thing was 21 meters from top to bottom, then yeah, that looks like it's about a quarter of the way down, right?
Could be.
A little bit more than a quarter of the way.
It's not quite that far over there. So anyway, we know its position, and I think the very best way to say its position is, let's use a component vector for that. Let's say that the position is 9.0 meters in the x direction, and what is that, 5.9?
5.9.
Negative 5.9 meters
in the y direction.
Right, so it's 9 meters over, 5.9 meters down, right? And now let's look at the velocity at that point. We could write the velocity two different ways. Since they don't say angle magnitude velocity, technically speaking, if we do the velocity, we could say that it's 8.2 meters
per second in the x direction.
In the x direction
plus negative 10.8 meters per second in the y direction. You could get away with it.
But chances are, if they say velocity on a college test, they want you to draw a picture of it.
Yeah, and they want you to figure out the hypotenuse.
So let's go 8.212 8.212 over. So we go back to the accurate version, right? And 10.78.
Now we got to
down.
go hypotenuse.
Right, and then we're going to find the speed of it, which is the magnitude of the velocity vector. That's going to be the square root of
8.212 squared.
8.212 squared plus
10.78 squared. Now, you don't have to worry about the negative. We already showed the negative down here, and it's all good. We're just trying to figure out this overall hypotenuse of the speed.
Besides, your TI calculators are dodgy when you put
Yeah, don't do it.
negative squared. Okay, so that's 13.55. And you would say that's the speed. At 1.1 second, if somebody said, what's the speed of it? You'd say the speed is 13.55 meters per second.
Because it incorporates both of the horizontal
Right. It's
and
not this
vertical
one, it's not
speeds.
this one, it's the hypotenuse. right?
It's together. That's why we call this two-dimensional motion.
And then that angle there is going to be the inverse tan,
Opposite
opposite over
the
adjacent.
angle,
Right? It's going to be a
Opposite
number bigger than
10.78.
45, right?
divided by 8.212.
Okay, so a second tan of 10.78 divided by 8.212. So we expect a number bigger than 45, and it delivers 52.7 degrees. Right, so if you had to say it with like a couple numbers, you'd say about 14 meters per second, although it pains me to do that, at an angle of about 53 degrees below the horizontal.
There you go. We've done it, kids.
There you go, in 6 minutes and 46
Oh,
seconds.
code word.
Code word.
Code word for this one is going to be Gangnam style.
Gangnam style.
Whatever it is.
Yeah, whatever that is.